Welcome to the first lesson, Programming the Commodore 65 in assembler.
Producing mega games
Not
on
really
the
on the
assembly
assembly
line.
line, but in assembler. And the first thing that you always will do if you learn a new language is to write this hello world, or let's skip the world, this hello program. But of course we want to do this time in assembler. But before we do this, let me show you this program. So this is again a basic program, and you should, if you consider the last lessons, completely understand what it does. It prints also this hello by poking the characters directly to the screen. And this is the very first program that we want to do now also with assembler. And by the way, the behavior is really very close to the assembler, and this is also why a basic program written in nearly only pokes is also often called writing basic in assembler style. So now let's have a look at our first assembler program, which again comes in the look of a basic. So, and here what we are doing is the following. So this is basic, but what the basic does is only to write the program into the memory. So we are writing all this data into the memory, and then we are jumping to that location and we are executing this program. So first, let's do it. Okay, this was now directly scrolled away. So let's do it. You see here the hello. But what happened now? So after everything was poked into the memory, the data is lying in like this in the memory. And then by using this command sys, there is here in the processor of the Commodore 65, there is a special memory location, or a special memory cell, not part of the memory, where the processor stores the so-called program counter. So this is the next place in the memory where to fetch the next command. So by sys 500 we have set it directly here to the first number we have poked before into the memory. And now the Commodore 65 knows how to interpret those numbers as commands. And if he comes to this number, the Commodore 65 knows that this command, this number, symbolizes the command LDA. We will later see that there are different versions of LDA, and each version of such an LDA has a different number. So by this number he knows that here is now the version of this LDA that is followed by exactly 1 byte as a parameter. And of course he also knows what this command expects him to do. So LDA means load data to, or load to accumulator. So accumulator is another, it's called register, so another small memory cell where the processor can store something. So because of this command, he knows that he should take the next byte and load it into his accumulator. And then, since he knows that this command has 2 bytes, one symbolizing the command itself and one symbolizing the parameter, he knows that his next command will be at that location, and so because of this command and knowing that it has a size of 2 bytes, the Commodore 65 increases the program counter by 2 and then fetches here the next command. And here again he knows what this number means. In this case it's an STA, which means store what you have in your accumulator to a location. And since we have here this special version, there are also different versions of the STA command. In this case we have the version where the next 2 bytes give the address. So if you want to give a complete address, you always need 2 bytes because you need to address an address room of 64 kilobyte, and for this you need 2 8-bit. So because of this he stores it then here into 800, which is 800 hex, which is exactly the upper left corner of the screen. And this is why there is then the H of hello, because 8 is the ASCII code of H. Or not the ASCII code, but the screen code of H. So, and then since he knows that this version of STA now has a size of 3, he increases his program counter this time by 3. Or first, we have now here written this to somewhere else in the memory and see then the 8 or the hello on the screen. So now here the program counter is increased. Now he fetches this. Oh surprise, this is again an LDA, but this time he should store 1 in the accumulator. And then he continues, he stores the 1 in the accumulator, and then he writes it to the memory location 1 after. Here is it. Then he stores the 12 into the accumulator and writes it to this memory location, and so on until we have here the hello, and I skipped here the O, the complete hello then written on the screen. An interesting thing I want to mention here is, as I explained already before, so if you have a look in the documentations or in the wiki or somewhere in the internet, you will see that there are many different versions of most of the commands. So there is, for example, this one, this LDA that we have used, which is followed by a constant. So he directly takes this 8. But there are other things. So you for example, here we can load from a specific memory area. Of course, in this case, the LDA command would have in total a size of 3 because it would be followed by a complete description of a memory location, and the memory location need to be described by 2 bytes. And there are many different others. I will not go into detail on them because you can read them also in the internet. There is a special thing which is handling the 0 page, which we will have a special lesson on. But the interesting thing behind this is that all these LDA commands are in reality different numbers. And because of those different numbers, Commodore 65 knows then, or can distinguish between those, because this is important because some of them have a size of 2, some of them have a size of 3, and for other commands there would even be the possibility that there is only a size of 1. So this is how you can write an assembler program. What I have not mentioned here is this last command, this 96, which stands for RTS, return from subroutine, which jumps then from this assembler program back to the basic. But of course, this is not how you want to write your programs if it becomes more complex. This was more in the sense of explaining. So now let's have a look how you would do it in reality. So, and in reality, you would write, or you will write your assembler program in a text editor, and then later use an assembler to compile it or to assemble it down to a program. So let's first have a look at the lower part, because this is the program. So this is exactly what we have poked before, but you see here now much clearer what you are doing. So you don't write here a cryptic number, you write here really the command LDA. So we want to load into the accumulator the 8, and then we want to store it into this memory location. We load next the 1. We want to store it into this memory location. We load then the 12. And this is all in hex, so you see here C, but it is 12, and we want to store it in this location. You know the hello has 2 L's directly after each other, so we could load again here this and then store it to the next location, but if there is something in the accumulator and you store it, it's not removed, so we just can use it again. So we store it first in this location, then we store it into that location. And then we need the last letter, the O, which we store in that location, and then this RTS, we jump back. Basically, that's it. But now the only additional things is some additional frameworks that you need. And here it becomes now to get a little bit specific to the assembler you are using. So I am using the TASS, so it's TASS. If you are using another compiler and another assembler, this might be a little bit different. So the first thing and the most important, or all the things are important, but what you see here is the location where you load the assembler into in the memory. Yeah, the assembler needs to be loaded somewhere into the memory to be executed, and this starting location has 2 important meanings. The first is that it will be this will be transferred into 2 byte, and those 2 byte will be the prefix of your assembler file. And when you load it, it will be loaded then into that memory area. But the second thing, which is also very important and which is often forgotten, is that this is also the starting point for the assembler to count. We will see this later again. We have this here a second time. And the next thing is now pure data. And what we are doing here is a funny thing, because what we are doing here is now exactly the opposite thing from what we have done before in this first example with the assembler. You remember? We did mysterious pokes to write numbers into the memory, and at the end this was an assembler program. And what we are doing here is the same. We are writing here some mysterious numbers at the beginning of our file, and this ends up in some basic commands. And maybe one more word to this location. The starting location, this is then also where the assembler again starts to count, so he knows that the first command, so this LDA, is at this position, and so because of this he will automatically know that this command will be at position 2102, because this has a size of 2. And this becomes important if you add here some additional jumps. So a jump is like a go-to. So if you have here a jump and you say, I want to jump to, and here you work with labels, I want to jump to second start, and you give then here a label which is called second start, you would directly jump over this RTS and continue your code here. But the important thing is that if you are at the end have an assembler program and this is poked into the memory, that this is no longer a label. This will be replaced by a number, and based on the starting point, the assembler will calculate this position and then will give exactly this number to here. So in reality, here is then something written like jump to about to 1, and maybe this is 5, this is 5, this is then no longer exactly 5, but so about 32, which would be then here. Yeah. Okay, but let's remove this. And after you have written this, you need to compile or to assemble this to a real file, to bring it to your disk, and then to start it. Maybe one thing I could show is the command line, how to assemble it. So to assemble it, this is really no big thing. So you need just to give the path to the executable of your assembler. And then you need the command lines that the command line options that you can read from the from the manual. So in my case, I want here just to have a plain assembly. I want to have it for this processor, which is the name of the processor that is used in the Commodore 65. Then this is the text file. We have had a look directly before. And then I need to include some additional libraries. This is now a specific thing for this assembler. And I want to have this name for my program. So I wrote this in a batch file. I just double click it, execute it, and then I have my PRGA. And I need to bring this to a disk to load it into the Commodore 65. And now let's have a look at this program. So then let's load this assembler program. And before we are executing it, let's have a look at it with list. List, of course, only displays basic. So let's see what happens. And here, the big surprise, we see some basic commands. And do you remember the upper part of the hex or of the text file that I've showed you, where I showed we are writing here just some mysterious numbers in? Those numbers are directly the numbers that result in those two basic commands. And those two basic commands are important for starting the assembler. When the Commodore loads this, he will load first those two commands, and after is it the real assembler program. And you know here, you see here the sys, which goes to 8448, which is exactly in hex this 2100 that we had for the start of the real assembler program. So what this does is just jumping here to the assembler program. And this is exactly how it also was done for the Commodore 64. The only difference is that we have now here a second command, or it's the first command, but this was not there for the Commodore 64, because what we have to do is to jump to the bank 0, because the program will be loaded into the bank 0. But if we would do some sys commands without this, they would try to execute it on the bank 1. So because of this, this header looks a little bit different. And now let's execute the program. And what we executed in reality is we executed 2 lines of BASIC, and after this we completely executed assembler only. And in a big assembler program you would never jump back to the BASIC, you would stay in the assembler. So with these commands you should already be able to write some smaller assembler programs. We will continue in the next lesson with some additional commands. Until then, have fun with experimenting with the assembler. See you then. Bye.